Hello friend, welcome to your YouTube channel Engineering Choice. So we have uploaded a few videos on the simple season strain, and now today we will come with new videos on the new topics. Okay, so these are the topics that we have covered in the previous videos. So let's today we will start with the new topic, that is elongations and stresses in the bar of uniformly tapering rectangular section. Okay, so in last video we have covered the derivation for uniformly tapering circular section, and today we will cover the derivation for the uniformly tapering rectangular section. So without wasting time, let's get start with our video, and I request everyone, please like, subscribe my channel for getting new videos. Just click on the bell icon. So I already explained to you, I am planning to upload all the subjects, all the videos which are related to civil engineering subjects. Okay, so let's start with the our today's topic. So today we are going to discuss the derivation of the calculation of elongations, means change in length of tapering rectangular section. So basically our main aim is calculate the change in length of this rectangular tapering section, and the formula for the change in length is general formula for the change in length that we are studying in last few videos, that is PL by AE. So main thing is what, just calculate the change in length. So for that change in length we require P, L, A and E, where P is what, it is the axial force which are acting on the any section or any body. L is the length of that body, A is the area of that body, and E is the modulus of elasticity. So now here the main task is what, to calculate the area. Okay, because this section is a tapering sections and we don't know the exactly area of the particular sections. So that's why what we are doing, we are considering small element, we are derivating it, and then we will go to the calculation of area. And for the calculation of area we require the dimension, correct? So in last video we have seen that for the circular section, first we have calculate the diameter, that is d dash, but now here we have to calculate the width and thickness, because in circular sections we required, in last video in circular section we required diameter to calculate the area, because that was circular section, but now here rectangular section is there. So formula for rectangular section, either b into d or b into t. So main motto is what, we need to calculate the b. Okay, so let's start with the derivation. Consider a taper bar of length l, constant thickness t, and width varying linearly from A to B as shown in diagram. So first, for this derivation, so we are considering the length of the tapering bar is L. Okay, first we are considering length of this tapering bar is L. Then constant thickness T. So from first to end, okay, from first to end we are considering constant thickness of that bar is T. Then after we are considering width varying linearly from A to B. So width is varying linearly from A to B. Means at left end we are considering A as a width, okay, and at right end we are considering width as a B. So that width is varying from constantly from A to B. That we are considering for this type of derivation. Take a small differential element at a distance x. So just take the small differential element at a distance x from any point. We can consider from A point or from B point. Any point we can consider that element distance. Okay, but now for these derivations we are considering it, the distance is from left end. So x is the distance of that small element from left end, and the length of that small element is dx. Length of that small element is dx, and the width is b dash. Okay, so at this point we are considering width is b dash, because we don't know the exact width of that location. That's why we are just assuming b dash. And lastly, thickness of that element, obviously t, because we are considering same thickness from a point to b point or throughout the section, so thickness will be same. So this is the general data that we require to calculate the actual change in length for rectangular section, tapering rectangular section. So just apply the linear formula or the interpolation formula to calculate exact value of b dash in the form of a and b, in the form of a and b. So for that, what we are doing, first we will focus on the overall section. Okay, first we will focus on the overall section. So maximum width minus minimum width, that is b minus a, divided by length of total bar. Okay, length of total bar. So b by a, sorry, b minus a divided by l. Similarly, due to the interpolation formula, we will take that b dash as a maximum. So b dash minus minimum a divided by length between these two width x. So due to that linear formula, we have considered this formula: b minus a divided by l is equals to b dash minus a divided by x. But our aim to is what? To calculate this b dash. Our main aim to what? To calculate this b dash. So just take this x in right side or left side. Take this x on left side. So here b minus a by l is equals to b dash minus a x. Just take x is on left side. So b minus a by l whole multiplied by x is equals to b dash minus a. Take this term is on left side and this is on right side. So the term is as it is, but just we have changed the side, left and right. We require b dash, so just take this a on right side. So the new equation is b dash is equals to a plus b minus a. This term is as it is, b minus a by l whole multiplied by x. Okay. Then next, okay. Then next, we need area to calculate the change in length. So area for this bar, rectangular bar is b dash into t. Area is what? B into t, b dash into t, where b dash just we have calculated over here, a plus b minus a divided by l into x. So just put this total term as a b dash, okay, a plus b minus a by l into x, okay, and take this t as it is, okay, t is as it is. So total area of this tapering rectangular section is a plus b minus a by l into x whole multiplied by t. Okay, but actually we are focusing on the change in length, and the formula for change in length is delta L is equals to PL by AE. Okay, formula for change in length is delta L is equals to PL by AE, where P is axial force and we have considered P as axial force, and L. L is dx for that tapering section, small section. Okay, we are applying this formula on the small element. See here, we are applying this formula in small element. So length of that small element is dx. Length of that small element is dx. Okay, so just consider this L as a dx. A just we have calculated over here. See, a plus b minus a by l into x into t. This is our total area. Okay, this is our area of section, and E as it is. Okay, now here we can see dx is there and we have applied this formula on the small element. It means to calculate the actual change in length, we need to take the integration of this term with respect to the L. Okay, so that's why The total elongation we can calculate by limiting by taking integration and equating it to the limit or considering limit 0 to L. So delta L is equals to take this total term is in integration. Okay, this total term in integration. See, okay. So now next is what? Take a constant term out of the integration. This P, T, and L. These three terms are the constant terms. So just take this constant term out of the integration. So the equation will be WL is equals to P delta L is equals to P by TE integration of 0 to L dx divided by a plus b minus a by L into x. Now we need to take the integration of this term. Okay, and we have one formula, mathematical formula for this integration, that is integration of integration of 1 by x into dx, integration of 1 by x into dx. I think I have written that formula over here. Yes, integration of 1 by x dx is equals to log of x. So we are considering this term as a x. Okay, this total term we are considering as a x, and the integration of that term is log of x, means log of a plus b minus a by L into x. But just we have seen in the last derivation, or it is mathematical term, if x is there, so we need to take the derivative of that term again. So again we need to take the derivative of this term, and this term is in numerator, so we need to take as in numerator, derivative in numerator. Okay, so d by dx a plus b minus a L into a, means derivative of this term. In short, what we are doing, we are calculating we are taking derivative of this term again. Okay, so P divided by TE in bracket, this term is as it is log of a plus b minus a by L into x, as it is. Just take the derivative of this term. So derivative of x, a is what? A is a constant term, so derivative of a is 0. Okay, and the derivative of b minus a by L into x. Okay, it's like that. Just derivative of 2x is equals to what? 2. Derivative of 2x is equals to 2. So this 2 means constant term is this b by b minus a by L. So this will be as it is. Now here we have taken integration, then we have taken derivative by parts. So now we need to put the upper and lower limit in the equation. Okay, so just put upper and lower limit in the equation. So before that we are taking constant term out of the bracket. Okay, so this is a constant term, so just take it out of the bracket. P divided by TE as it is. Okay, 1 divided by B minus A by L. So log of A plus B minus AL, B minus A by L into X, 0 to L. So just put upper limit first and then minus of lower limit. It's a mathematical term. Okay, so this is total term into L, means just put L at the position of X. So log A plus B minus A by L into x, just put L. Similarly, the total term as it is, and just put x is equals to 0 in the lower limit. Okay, so now if you see over here, this term will be as it is. Here L will get cancelled, and this term total bracket is multiplied with a 0, so this will get cancelled. So remaining term is what? Remaining term is this one. Okay, remaining term is, okay, remaining term is this log A plus B minus A minus log A. So this is a total remaining term. We will see it. Okay, the remaining term is delta L is equals to P L by TE, B minus A, B minus A, this B minus A. Now from this bracket, A plus B minus A, because L get cancelled. See here, A plus B minus A, because L get cancelled, and in last bracket here B minus A by L into 0. So this total bracket will 0. Remaining term is log of A. So here we can see log of A. So here also log A positive, okay, A positive and A negative will get cancelled. So here the remaining term is log B minus log A. So again mathematical term, log B minus log A, that we can write log B divided by A. So PL divided by TE in bracket B minus A log B by A. This is our term change in length. Now I think we don't have any options now to continue this derivation, so we can say that this is our final elongation of rectangular tapering section. So just remember this formula, okay, just remember this formula to calculate the change in length for rectangular tapering section. So in previous video we have gone through the uh, change in length for uniformly circular section. So whatever formula we have derived in the last video, so this formula and that formula you should be remember for the any type of exam. Okay, that it will help you in the MPSC, UPSC exam. If tapering section is given, so you can apply this formula directly for the rectangular and the circular section as per the requirement. Okay, no need to go with this derivation. But yes, for the university exam point of view, these questions will ask for few marks, maybe 2, 3, 4 marks. The derivation, derive the formula for change in length of rectangular tapering section or the circular tapering section. Okay, so remember this formula. Thank you. In next video we will see the numerical or the tapering section. Okay, so both numerical we will cover in the next video, circular tapering section as well as the rectangular section, rectangular tapering section. Okay, so again I request everyone, please, if you are uh, getting some knowledge from these videos, from my videos, so please like, subscribe my channel and hit on the bell icon, so you will get that notification uh, quickly. Okay, and as I have discussed in last few videos, I am planning to upload all the videos which are related to the structural engineering, like engineering mechanics, SOM, structural analysis, design of steel structure, design of reinforced concrete structure, design of pre-stress, okay, and much more. And we are planning for some software videos also, but for that friends, we need your support, okay, subscriptions and the number of views and comments. So if you have any doubt or you require anything else other than these videos, so please uh, comment your questions in the comment box or your thoughts in comment box, so I can upload that types of videos also. Thank you.